This is a recap of function notation and evaluating functions. We're going to use all of these skills that we talked about earlier in the year in the next upcoming sections. So let's look at the original way we used to write functions. Y equals 2x plus 3. That's the original way we used to have y equals. We used to usually be given an input, usually an x value. We'd put it in there, substitute it, evaluate it, and get an output value. And then we would eventually end up with an xy coordinate point. An xy coordinate point. All right, so we changed the way we looked at it this year, and we created, let's keep the same problem, function notation. This right here, let's change the color and say that's function notation. And we can think of this and say this portion here as f of x. That's how it's spoken, f of x. So you'd say f of x equals 2x plus 3. All right, and we're going to break this apart and say that f, or g, or h, whatever here, and that's the name of the function. That's the name of the function. If we have more than one function happening, it's good to know that we're referring to this one specific one here. So that's the name of the function. And x, right in here, is the input variable. And that can be x, can be t, if it's time. And if we go ahead and look at the same function again, function f, we see that x is here twice. All right, but this is still, that's the input. So when I see this here, it is an f times an x equals, this right here is actually our output. All right, this is the value that we are going to substitute for this x here. And then when we go through and evaluate, we'll find what this whole output is, what y is. So let's do an example here of what I'm talking about. If we want to find the value, so let's say we were going ahead and doing this the old school way, and we wanted to find y when x equals 5. And we would have gone through and say, okay, y equals 2 times 5, substitute when x is 5, plus 3, so y equals, let's see, 10 plus 3, y would equal 13. And we could put it together as a coordinate point, as an x and y. We would say 5, 13. And now let's look at it when we have a function notation version of it. So we have f of x equals 2x plus 3. And I'm just going to say to find f of 5. So this is what we will evaluate it at. So we are going to evaluate at x equals 5. That's what f of 5 means. So we'll say f of 5 equals 2 times 5 plus 3. This is saying take your function f, evaluate it at 5, and tell me what you get. So 2 times 5, 10 plus 3, so we get 13. So we get f of 5 equals 13. And when we look at it more specifically, this is actually what y is. Since this is what y is, that's what y is. And then this still told me what I wanted x to be. And we can write it as the coordinate point 5, 13, or we could write f of 5 equals 13. Here's our x and our y. Here's our x and our y. Let's practice evaluating now that we know and remember function notation. So we're going to be given a function. This is function g, and our input is x. So we're going to find out that g of x has this rule, -3 minus 2x. And then I would like to find g of -4, g of -4. So in order to do that, I'm just going to put -4 as my input. So, -3 minus 2 times -4. So wherever I see an x, no matter how many times I see an x, I'm going to put in a -4. And then I'll go ahead and evaluate. And I have a 5 left. So I know that g of -4 equals 5. And I could plot that point, -4, 5, on an axis somewhere. Because this is my x, and that's my y. All right, let's look at another example that's a little more difficult. This is given that h of t is equal to 4 times t squared. And I'd like to find h of x minus 3. Oh, let's change it to t minus 3. There we go. All right, so we'll take h, and what would I like to evaluate? I'd like to evaluate h at t minus 3. I can put anything I want as a substituted value. So instead of writing t, just as I'd put in another number, I'm going to put t minus 3 squared. And this is where I'm just simplifying this side. I'm not calculating anything over here. I'm not removing anything, adding, subtracting, leaving this. This says the function h evaluated for this particular expression or value. So 4 times, well, how many do I have of these? I have 2, right? So we want to remember that. We just did that in the last section we did. We have 2 up here, we got a FOIL. So 4 times t squared, so firsts, outers, inners, and then lasts. And then when I simplify, I have t squared. These are joining up together, and I have a plus 9. And then my last step will be to distribute this 4 in by multiplying to everything. So 4t squared minus 24t plus 36. And that's what my function h evaluated at t minus 3 comes out to be. And this is going to be something that we look at in the next section, the concept of evaluating a function with another function inside.